So CS150, we're continuing on with our study, and we're going to take a look at arrays, which are going to be a way of organizing data for us. So if you look at the definition, an array is a collection of variables that are all of the same type, or a collection of related data that are all of the same type. To declare our array, what we do is we get the data type, is the int, double, char, float, along with the name and a number of elements in brackets. So for example, here we have a array called name that is of type character and has 4 elements in it. Each array item gets identified by an index, and C++ starts their identification with 0. So there'd be name 0, name 1, name 2, name 3 would be the 4 characters that make that up. And note that there is a name 0, but no name 4 again, because we start our indices with 0. So as usual, you can combine the initialization with the declaration. So both of these int numbers 5 with the 5 zeros works. Or not leaving it blank and putting in the 5 zeros. I prefer the top one, obviously, because we're going to learn later on how to declare dynamic arrays that are arrays that can grow and shrink in size, but you won't see that until 151. What you can do is you can reference any element within that array using a variable name or a number. So you give the array name, and then in square brackets, you give the expression. So for example, if we wanted to output the third element, we would see out name 2. Or in this case, with the example, I is equal to 2, see out name I minus 1 would output 2 minus 1. It would output the second element in that name array. So here is a pictorial depiction of 10 integers with 34 stored in the 6th element, or index 5. In this code, we would declare it as a list of type integer that is of size 10, and we would set the 6th element or list indexed at 5 to 34. So what happens in memory is typically the environment will set aside contiguous memory. And so if we declared an array of type double with 5 values in it, each one would take 8 bytes of storage. So we would set aside 40 consecutive memory locations, and say it starts at address 4020. For the first value in the array, we would skip ahead to 4028 for the next value in the array. And so you can think of these as little blocks in consecutive memory that hold the information contained within the array. The one thing to be careful of, is the out of range error. So for example, if we tried to get the 6th element, CN list 5, there's no list 5, even though we said it was 5, it goes between 0 and 4. The compiler will still compute the necessary offsite, and it may write over something, or may give you a runtime error. Some compilers are kind of clever on detecting this, so really depends up to the compiler writer and the runtime environment. You kind of don't want to leave those things to chance when you're programming. So just be careful with the bounds in the array. So we can use them like any other simple variable. For example, we could output the 4th element, see out number 3, or we could pass an individual element to a function. And arrays work really, really well with for loops. So in the first example over on the left, we can iterate through the array starting at index 0, going up to but not including 5, and then just output each item. It may be good to have an inline or a space in between those. So they work really well with for loops, and those are good for initializing, reading the data into the array, printing it out from the array, keeping a running sum or computing the average, finding the largest element in the array. We're going to see some of those algorithms a little bit later on in this module and chapter. You can also treat the array in some ways as a single entity if you're passing it to a function, but we have to be somewhat careful. We pass the array itself. Here we're passing A, and we pass its size separately. Arrays are always passed by reference, but you don't need to add the ampersand symbol in order to do that. And since you're modifying the original, you can't return an array from the function. So a lot of times the functions involving arrays are void. So this one doubles every element inside of A. And here we have the definition and the invocation as to how that would work. The declaration would obviously be the same as the first line of the definition, but with a semicolon. For right now, until you get to 151, you can't declare a variably sized array. We'll get to why that is in 151, but trust me, we will get there. But you can use a trick called a partially filled array that makes an array of a larger size than what you need and then has a variable that indicates how many elements you've used. So you need to declare a maximum size, load part of the array, and then keep track of the high water mark or the maximum index. And that way you always stay within the meaningful data and you won't have to worry about using any tricks from CS151 in order to do that. So one of the basic algorithms that you'll want to do with an array is to find the maximum element within an array. So imagine you have an unordered list of items that you've stored in the array. And what we want to do is we want to find the maximum value in the list and also where the location of that maximum value is. So how do we do that? Well, what we do is we start with the first element and we say, hey, that's the largest one that I've seen so far. Then we go through the list one at a time and compare it with the largest one that we've seen so far. If it's bigger, make that value the largest so far and adjust the location. And then we quit at the end of the list. So, you know, if we had 10 numbers in a list that were integers, we'd say we'd declare an integer called largest and set max index equal to 0. And that says that we found in the first location, and then start from index 1, go all the way up to index 10. And if the list at the maximum index is less than the list at another point that we are going through the array, then set the max index to the one that's bigger. And at the end, we'll have largest value. So we just go through them one at a time, and whenever we find a larger value, we set that equal to the larger value. So next time we'll do a little bit more work with arrays. Thank you so much for watching.